Okay, hello and welcome back to another exciting installment of our math video lessons. Today we're going to look at the trigonometric ratios. Right away I just want to get it out there. A lot of you talked to me about some of the things Mr. Miller said about me in the last video. You're pretty upset. I got to admit I was pretty upset as well. Mr. Miller is somebody that I really look up to. Well, not physically. Obviously, I don't look up to him. I mean, he doesn't even clear 5 feet. But you know what? Never mind. Okay, so we're going to use the trigonometric ratios to find missing side lengths in triangles, and we'll just go through a couple examples. So here I have a right triangle. I have a given angle and one side, and I'm going to find the missing two sides. So how do I do this? Hopefully it's right on the tip of your tongue. You are going to use one of the trig ratios, and you're going to remember them by SOHCAHTOA. Just a quick reminder that we're only going to use these for right triangles. Right triangles only. Okay, we can make right triangles inside of other ones, but if I want to apply a trig ratio, I have to be looking at a right triangle. Okay, so once I've identified that I have a right triangle and I would like to use a trig ratio, the next thing is to label the side lengths appropriately. So I'm using a reference angle of 25 degrees here, and if I look at side x, I want to know is side x opposite, adjacent, or hypotenuse to 25 degrees. And so you're going to tell me quickly, Mr. Griffin, I know that that is adjacent. And you'd be absolutely right. And if you look at side y, you would tell me that that is opposite. And again, you would be right. Okay, so once I've got these sides labeled, that leaves, I should say, 15 as my hypotenuse. Remember, the hypotenuse is always across from the 90. So now, if I start with side x, I'm going to want to use a trig ratio that includes an adjacent side, and in this case I have 15, so hypotenuse. What's the correct trig ratio that has adjacent and hypotenuse in it? And you said cosine, and you're absolutely right. So I'm going to write the cosine of 25 degrees equals the adjacent side, which in this case is x, divided by the hypotenuse, which is 15. That's my ka. Cosine is equal to adjacent divided by hypotenuse. Okay, so once I've got this ratio set up, it's a question of solving for x. So if I'm being really exact, how do I get x by itself? Multiply both sides by 15. A little better there. And I have found that 15 times the cosine of 25 degrees is equal to x. That's my exact answer, but if I want to know the actual length, I'm going to do the multiplication. So I'm just going to switch sides here, but x equals 15 times the cosine of 25 degrees, if I put it in my calculator, is 0.9063, and it goes on and on. And just to remind myself, that means in a right triangle with a 25-degree angle, the side adjacent to the hypotenuse is 0.9 times as big as the hypotenuse, the adjacent to the hypotenuse. And when I multiply that out, I get that the adjacent side is about 13.59 centimeters. Good. Let's do the same thing for y. So if I'm looking at y is opposite my 25 degrees. I'm again going to use the given measurement, which is 15, which trig ratio is best for opposite and hypotenuse. Opposite hypotenuse is the sine ratio. So I'm going to write that the sine of 25 degrees is equal to the opposite side, in this case y, divided by hypotenuse. And this tablet always does that. Similar operation, I'm going to multiply both sides by 15, and I'm going to get 15 times the sine of 25 degrees. You know what? That's not working for me at all. Quick change here. Should make it a little better. Okay, erase this mess. I apologize. Sine of 25 degrees is equal to y. That's my exact answer. Again, it looks terrible. Maybe Mr. Miller's right. Oh. Okay, and so that's exact. Approximately y would equal 15 times, when I type sine 25 in my calculator, I get 0.4226. The opposite side is about 0.42 times the hypotenuse. And so when I work that out, I get 6.34. That didn't work at all either. I've lost my techno savviness here. So final answer, y is 6.34. Could say, Mr. Griffin, I wanted to use the Pythagorean theorem for the second side. No problem. Okay, but we're just practicing some trig ratios here. So one more example. Another right triangle here. I'm going to use SOHCAHTOA again. And so again, labeling these sides right away to start. What is x with respect to the 50 degrees? You said adjacent, you win the prize. And y with respect to the 50 degrees? Hypotenuse. Yes. All that talent and good looks. You're a marvel and a wonder. Okay, so if I'm starting with x, what trig ratio should I use? I didn't describe this one, which I should have. What is 7 meters with respect to the 50 degrees? Well, it's what's left. It was obvious, sir. That's why you didn't say it. Okay, thank you for the criticism. What trig ratio can I use to find x? I want adjacent. I have opposite. Adjacent and opposite, that would be TOA. So the tan of 50 degrees is equal to the opposite side, 7, over the adjacent side, which in this case is x. So it's a little trickier here because x is in the denominator. That was the point of this example. But I would do kind of the same thing here and multiply both sides by x, kind of find a cross product, and get that the x times the tan of 50 is equal to 7. And then if I get x by itself, how would I do that? I would divide both sides by tan of 50. And again, I have an exact answer, but I really want to know approximately what this is. Let's do this in one step. 7 divided by the tangent ratio of 50 would give me 5.87 meters. Okay? And then lastly, if I want to find y, which is the hypotenuse, I'm going to use my given value again, opposite and hypotenuse. I remember that that is the sine ratio. So the sine of 50 degrees equals opposite divided by hypotenuse. Again, I have a variable in the denominator. I'm not going to panic. Nice and easy. Y times the sine of 50 equals 7. And then y equals 7 divided by the sine of 50 degrees. A little punch into my calculator, and I have that y is approximately 9.14 meters. Okay? Hope that helps, and you get some practice in using your trig ratios to find missing side measures. Good luck, and may the force be with you.